Hi, Mr. Shopke. I spent my entire project giving you an itinerary on how you are now going to solve related rates and optimization. So I figured I might as well give you a tour of my own spring break. So, before I actually have my spring break, I need to leave first. So on Monday, Nate and I are both leaving for our spring break trips. I am traveling to DC on a plane going north at a rate of 240 miles per hour, while Nate is going to LA on a plane going west at a constant rate of 300 miles per hour. If our planes leave at the exact same time, what is the rate of change of the distance between us exactly 2 hours into our flights? What a great way to use related rates. So, first, I have to figure out what my variables are. As this is a related rates problem, I need to figure out what dn over dt is and what dj over dt is. As I'm Jess, I'm going 240 miles per hour, whereas Nate is going 300. I need to figure out d, what the distance is, as well as dd over dt, the rate of change of that distance. So, what other to do than make a triangle? I'm going north, so straight up. Nate's going west, so horizontal. 240 miles per hour is my rate of change, and 300 is Nate's, but how would we find our constants? Our plain old distances, per se. Well, I have just the question for you. We all know distance is rate times time, right? And t is 2 hours in this scenario. So I simply multiply my rate of change times 2 hours, which is 480, and the same thing for Nate, which is 600. Now I have our rates and our scalar amounts. Back to our triangle, we need to find our total distance. Total distance and rate of change, which is marked by this line here, d. Now, I know you're thinking triangle, right? Boom! Pythagorean theorem. Instead of doing the boring old a squared plus b squared equals c squared, I did j squared plus n squared equals d squared, with obvious meanings. So now I'm using not dj dt, our rate of change, but j and n, our amounts, or our plane distances, not including time. So I'm 480 squared, Nate's 600 squared, and we don't know d yet. But if I pull out my handy dandy calculator, because it's all calculator problems, and it validates, then square root 590,400, and we have 768.374 right here. Now, I need to find dd over dt, which is, well, we already have d, which is great, but now we need dd over dt, which is the rate of change of that distance. So I just had to do the derivative and implicit differentiation. It goes from j squared plus n squared equals d squared to 2j dj over dt plus 2n dn over dt plus 2d dd over dt. Well, as you can see, that's some pretty complicated math. But basically, now we're grateful that we have everything but dd dt. So 2 times j, which is 480, times dj over dt, which is 240, plus 2 times 600, which is n, times 300 dn over dt, equals 2 times 768.375, which is d, times dd dt. Doing some math, that's 590,400 equals 1536.750 times dd over dt. Now, simply divide by 0.750, and you have it. 384.187 equals dd dt. To put that in words for you, because I know you love us to do that on the FRQs, the rate of change of the distance between Nate and I is 384.187 187 miles per hour 2 hours into our flights. Thank you, and be prepared for my next stop on my itinerary, the Washington Monument.